What's up, everybody? Mr. Kozad back again with a little special treat. Today, I'm going to walk you through example 5 from our 3.4 day 2 notes. We didn't have time to finish this in class, so this is such an important problem for you to know how to do, so I'm going to walk you through just example 5. So if you already have the 3.4 notes printed, get those back out. If not, no big deal. Grab a sheet of paper in your notebook and work this problem out with me as we go. All right, so as is the case, I go a little bit faster in the videos than I do in class. So if you need to pause, go back and watch something again, pause and work to try to catch up to where we're at, totally fine. If you're tracking with me, keep rolling. You probably won't need to fast forward, but some of you might want to. Totally up to you. So here we go. Write a quadratic function, okay, in standard form that passes through the points 1, -5, -3, -41, and 9, -125. And the hint that's given here is that standard form of a quadratic is in the form ax squared plus bx plus c. So again, that is called standard form. That's what standard form looks like. Okay? So our dilemma here is we've got to figure out a way to write this in standard form, but we're given 3 points that will be on this curve. So when x is 1, y equals -5. So if we take this point and we plug that into the equation here, let's see what we have. So I know that y is -5 when we plug a 1 in for x. So that's a times 1 squared plus b times 1 plus c. Well, if I clean that up a little bit, I get -5 equals 1 squared is 1, 1 times a is a, plus b, plus c. There's one of my equations. Now, if you notice here, how many variables do you have? 1, 2, 3. So let's do it again. Because if we have an equation with 3 variables, I need to find 3 equations in order to solve that system. So, pretty interesting that you were given 3 points. Not an accident, okay? So, the second point, y is equal to -41 when I plug -3 in for x. So, I'm taking that standard form and I'm plugging -41 in for y and -3 in for x. So then we go through and clean this up. I get -41 equals 9a minus 3b plus c. And looky there, now we have a second equation with a, b, and c. So you probably guessed what we're going to do next. Next, we're going to take this third point. We're going to plug -125 in for y, and we're going to plug 9 in for x. And we're going to clean that up. So we have -125 equals 81a plus 9b plus c. So what we have here is we have a new system of equations. We have a new system of equations that we can solve. Okay? So you know the process that we're going to use to solve this system. Okay? So what I'm going to do is I am going to take this system right here and I am going to copy it and I'm going to paste it over here on its own page so we have plenty of space to work. Okay, here we go. So let's get rid of this guy here. All right, our new system. So obviously, in my opinion, and hopefully yours too, the easiest the path of least resistance is going to be to eliminate C, okay? So when I do that, I'm going to eliminate C twice. So I'm going to take equation 1 and equation 2. So equation 1 is -5 equals A plus B plus C. And equation 2 is -41 equals 9A minus 3B plus C. Now, in order to eliminate C, I'm going to subtract these equations. So I'm going to go through and subtract each column. So -5 minus -41, that turns into 36. A minus 9 is -8A. B minus -3b turns into plus 4b. and we get 0c, which was our goal all along. So now I'm going to do it again. I'm going to eliminate c a second time. So this time I'm going to do equation 1, and I'm going to do equation 3. So again, that's negative 5 equals a plus b plus c. And then negative 125 equals 81a plus 9b plus c. Same deal, we're going to subtract each column. So we end up getting 120 equals negative 80a minus 8b plus 0c. So now what we have is we have a new system. Okay, we have a new system. It's smaller. It only has 2 variables. So our new system is 36 equals negative 8a plus 4b, and 120 equals negative 80a minus 8b. Now, if we wanted to solve this system, elimination would work pretty well. I'm going to take the first equation and multiply it by 2. Okay, so when I do that, I get 72 equals negative 16a plus 8b. And then I'm simply going to take that second equation that I have. I don't have to multiply that by anything. And I get my b's to line up. Now, do you want to add or subtract? If our goal is to get 0b, we're going to add. So 120 plus 72 gives us 192. And then I have negative 16 plus negative 80. That gives me negative 96a. Plus 0b. That was the goal. Okay? So to solve for a, we divide both sides by negative 96. And we end up getting negative 2. A equals negative 2. So then the next step is to solve for b. Okay? So I'm going to take that first equation. 36 equals negative 8 times a. But now I know that a is negative 2. Plus 4b. So that gives me 36 equals positive 16 plus 4b. Subtract 16 on both sides, and we get 20 equals 4b. Divide both sides by 4, and we get b equals 5. I'm going to highlight these just so we keep track. So I've got 2 of the 3 solutions. So now I need to find one more. Okay? So to find the last one, you pick any one of the original 3 equations. So I'm going to do the first one, negative 5 equals negative 2 plus 5 plus c. So negative 2 plus 5 is 3. Subtract 3 on both sides, and we get c equals negative 8. So last thing that we're going to do is we're going to put this all together in one equation, and we're going to say that our solution is, let's go Stratford Green. Y equals negative 2x squared plus 5x, hold tight, ran out of room, sliding that over a little bit, minus 8. And we put it all together. Fun, quick problem, okay? That would be really, really good to know how to do. Let me know if you have any questions. Go back and rewatch if you need to. You'll have a great night.